Good day. I cordially welcome you on behalf of NTI Audio. On a day like this, actually today we have beautiful sunshine outside, 22 degrees centigrade or 72 Fahrenheit. Would be a good occasion to take the lawnmower, cut the grass last time this year. But as you know, lawnmower are also an item of potential trouble with your neighbors, maybe if they are too loud or if they're used on the wrong time. And that brings us to the topic of today. How can we determine the noise, the emitted noise of a machine like a lawnmower or anything else in a way that is objective and reproducible? And actually, this is the sound power that we will talk about today. Let me please introduce myself. My name is Markus Becker. I am moderating this webinar and I'm assisted by Greg Schmiedle, our product manager. On the left-hand side, we see the topics that we have prepared for you, starting with a brief look on the motivation and the definition, the standards of sound power measurements. We will then take a closer look at the test setup and the test procedure before we step over to the practical presentation that we have prepared for you. After that, I will summarize the key topics or the key aspects of today's presentation and add some more tips and tricks. I expect that this webinar will last approximately half an hour. Well, to start with, the question that we are covering today is, can we determine how loud a certain noise-emitting device is? Can we do that in a way that is reproducible and objective? And one of the challenges we have to cope with is that such devices like this hand vacuum cleaner that we see here, they emit the noise in different directions with different levels. So depending where you stand, where you are positioned, you may hear the device louder or less. So we need some objective solution that is independent of this directionality of the noise emission. That is the challenge. The target that we are pursuing is to create a single value that represents the overall behavior, the overall characteristic of our device. Well, in order to explain the background, we would like to start with a brief look at three different terms. One of them is the sound pressure. Let's say we have a noise emitting device and we are positioning ourselves with a sound level meter in a certain distance to that device. And now we are measuring the sound level here at this position in the distance of the capsule to the device. However, as just stated on the slide before, this result may differ clearly depending on the position where we are. And for that reason, the sound power measurement has been introduced. Sound power means that we would kind of think of a virtual hull, a virtual bubble or ball around our sound emitting device and measure now the sound level at each point of the surface in order to determine the overall energy that is emitted by our device per time. And that energy per time gives us the sound power, which is an absolute value. There's a third value which you might encounter from time to time, the sound intensity. Sound intensity means that we are looking at a specific area, could be 1 square inch, for instance, and we are determining or measuring the sound, the emitted sound power over this area with our sound level meter. In order to make more clear the effect of these measurements, let us assume that we are now taking a step back. In other terms, we are increasing the distance from our sound level meter to the noise emitting device. So maybe you have noticed the sound level has dropped here on my display. It's quite obvious because I'm farther away from my device. Also, the sound intensity will drop because the sound power emitted through this identical square is lower, and that is why it is going down, the sound intensity. However, the sound power, the overall energy emitted per time through this hole, regardless whether it is larger or not, is still the same. And that is the reason why sound power plays such an important role for the characterization of such devices. Actually, there are different standards available that define the measurements and the environment of such a sound power measurement. Here you see the DIN, the German, the ISO International, the European standards, especially the 3744 will be subject in this presentation, but we also have American standards that are also describing this measurement. Now, when we want to measure this sound power, we need a practical solution, because what we cannot do is we cannot let our device float in the space and then walk around and make these measurements. We need a solution that is really feasible in practice. And the solution here is to apply what we call a half spherical microphone array. So let's start. We put the device on a plane, on a surface, on a hard surface. And for instance, we would place a virtual or maybe even a real half spherical array around that device with specific points where we will place our microphone. So we are reducing the number of measurements to a limited amount. And at these different points, we are measuring the sound level and summing that up to a result. Well, half spherical array is maybe a little bit complex or cumbersome to realize, to establish, and for that reason, there is also an alternative in the standard, and that is a cubic microphone array. That is much easier to establish. You're going to see that. So here we have straight lines, and on these lines, we have, again, our microphone measurement positions. Same as before, we are measuring here the sound levels and then summing them up to an overall result. So how does that measurement procedure look like? The first step would be we determine the reverberation time of the test room. That is, of course, crucial. Because as you can imagine, if I am doing this measurement in a very reverberant room, I will not only have the result, the sound level coming from the device under test, but there will always also be reflections from the walls from behind, which add up to the overall result. And that is, of course, falsifying the behavior of this device under test. So we need to know the reverberation time in order to calculate a correct result. Second, we need to establish these test points. And the standard here requires a minimum of 9 positions. And let me now flip briefly over to an Excel sheet that we are using internally. You see it here. So this Excel sheet helps us to find the correct positions. This graph, this sketch here comes from the standard, by the way, and it defines the conditions that need to be met to execute such a measurement. So we enter the dimensions of our device under test, and then we decide the minimum distance or the distance between the edges of this device under test to our measurement positions. In our example, we have 0.5 meter, but it could also be 1 meter or any other value. You see, as soon as I change this value, the corresponding data or results will change as well. Let me go back to 0.5 meter. So this Excel sheet calculates automatically the values to A, B, and C. You see that here if you look at the sketch. So these values are now indicated, and this allows you to establish this virtual cube in an easy way. Also, the software or this Excel sheet verifies whether these conditions are met. They are given by the standard. And also very important, we need to know the measurement surface. The measurement surface is the sum of the 5 sides of the cube, the sides and the top, not the hedged ground. The hedged ground does not go into this calculation, but the sides of these 4 sides plus the top side of this cube are going into the calculation of this overall measurement surface. We're going to use that later again. And here, by the way, you also see these 0.33 or 0.65 meter distances for the P1 and the P2. Okay, getting back to our presentation. That was the way how to determine the test points. Now, the next step would be to measure the levels. And now we have to execute actually 2 measurements per test point. The first one would be typically the background noise. So we switch off our device under test and just find out what is the environmental noise present at that position. And then we switch on the device and measure the noise coming, the sound level coming from our DUT. And we do that for each position, obviously. So at the end, we get the number of data. We get the reverberation time results, T. We get the background results, B, and the sound levels, L, from the device under test when it is switched on. This is a number of measurement results, and they are all now combined into the overall sound power result, and that is called LW. That is also given by the standard. This calculation is fortunately done by the software that I'm going to present to you, so there's nothing to worry about that. You just have to take care to correctly measure the individual data. So what equipment do we need for the whole procedure? We need a sound level meter, apparently. Let's talk about the XL2. In that case, we need the extended acoustic pack and the sound power reporter option. I will come back to that later. We need a measuring microphone, an ASD cable to connect the microphone to the sound level meter, a tripod to position the microphone. For the reverberation time, we need the DS3 Dodec loudspeaker, power amplifier. Then it is recommended to have a measuring rod available with a pen or a chalk in order to point out or to build up this virtual cube to know where the tripods or the microphones have to be positioned. And we need the sound power reporter software. The procedure, as just presented before, evaluate the reverberation time, and then place the microphone at these defined positions and measure the background noise and the level from the DOT. Here on this picture, we see the concrete setup as we did it here internally in our meeting room to execute such a measurement. So you see the hand vacuum cleaner here in the middle of the table, and then we established this virtual cube around it with the 9 positions where we're going to place our microphone in order to execute the measurements. And by the way, you remember maybe the 33 centimeter, 65 centimeter values there found here again. So that is the connection between the Excel sheet and our practical setup. Well, on this picture, you see an animation of the microphone positions, the 9 positions that are used, that need to be executed in order to acquire all these data we need for the sound power measurement and calculation. Okay, that brings me already to the practical presentation. Here I have an XL2 sound level meter with my 2230 microphone. On my PC, I have installed the Projector Pro software, which allows me to share the screen content of my XL2 with you so that you can see it. And of course, I have also downloaded the Sound Power Reporter software and installed it so that you can that we can later show you the calculation of the results. But first, I'm going to switch over to the XL2 screen, which you see here. And I want to show you how to proceed to acquire these individual measurements. Well, actually, there is a nice feature that we have prepared, and that is under profiles. You can download a predefined profile to your XL2, and this profile will assist you in executing the measurements in a very easy way. So we click Profile, select, and then we select the sound power profile that is already installed on my XL2. So you see up here, the bar already indicates me sound power profile loaded. I can now take a look what measurements can I execute. There are only 2 left because I only need 2. I need the RT60 measurement, the reverberation time. I will not show you that today because we have already had a webinar on that and it would take too long. But I'm going to show you the sound level measurements that we have to execute for our procedure. So I start, you see again the bar indicating sound power. Now, one last look at the range. Is it set correctly? Well, I have not very high sound levels, so the range seems appropriate. Otherwise, I needed to adjust it, but I can leave it as it is. And now all remains to be done is to start the measurement, and I'm going to do that. And now you see a measurement takes 20 seconds. That is defined by the standard. And here in the countdown timer, you see the 20 seconds being counted. And during that time, the instrument just measures what I call background noise in this case, and it already calculates the average over these 20 seconds. Measurement completed. You see up here, there's a question mark showing up all of a sudden, so I need to save my result. That's why I'm going with my cursor over here. I confirm, I say, yes, I want to save this test. And now, when I have loaded this sound power profile, you will see this entry in this dialog box, sound power. And when I click on that, the system offers me now 3 choices. Because I have to decide, has that been a level measurement of the device when it is switched on? Has it been a background noise measurement, or has it been a reverberation time measurement? Well, in my case, let's assume it has been a background noise measurement. So I select B1 and confirm. B1 is an identifier so that the PC software afterwards identifies or recognizes this measurement as a background noise measurement. And here you see this is the counter which will be incremented from cycle to cycle so that the system can always identify each measurement individually. So the last thing I have to do, I have to click on save in order to save the data on the SD card. And in this way, I would now proceed with every position. Of course, I would now do the level measurement with the device being switched on, then go to the next position and so on and so forth. I'm not doing that. Again, it would take too much time, but I have actually done that before and I can show you the results here in my reporter software. But before I open the data, I would recommend to you to click here on this new button, because now you can make a couple of selections. For instance, you can decide by which standard the result data shall be analyzed. So I stick to the ISO 3744. I can decide the frequency resolution, 3rd octave or octave. I could even restrict the frequency range if I want, for whatever reason, upper and lower limit. Here I can tick whether I want to get the sound power A-weighted and or Z-weighted. I leave both active. Then we have a special case. It could be that you can do your measurement or have to do them in a free field condition. So not in a closed room, but under free field conditions. And then you can tick this checkbox, and that will mean that you do not have to execute a reverberation time measurement, because under free field conditions, reverberation time does not make sense. But in most cases, I guess you will do the measurements in a closed room, and for that reason, leave this cleared. And then you can also decide whether you want to enter the distance data in metric or imperial units. Next tab, mapping, that refers to this identification of the measurement files on the XL2, as you have seen that. Charts, here you can amend the scaling of the charts that you're going to see in a minute. And last but not least, here under report, you have some choices to customize your report. You can exchange our logo with your own one. You can add a scanned signature if you like. You can already enter the name of the test institute and so on. You have a couple of choices you can amend here. So I confirm. And now my next step is to import the measurement data. Actually, I have 3 choices. I can click here on this link. I can click on the icon up here, or, and that is what I'm going to do actually, I can drag and drop the measurements. So here I have my Windows Explorer with the pre-recorded measurement results, which I did a couple of days ago. So I select all of them and just drag and drop them to my desktop. Okay, apparently there is one error in one of these data sets, but this is not so dramatic. We just confirm the software is robust enough to cope with this situation, so we just ignore it. And we see now here on the graph, the blue curves are the level measurements, the green curves are the background measurements, and down here, the pink ones are the reverberation time measurements. But let us first, before we come back to these curves, let us first edit some more information. For instance, up here, you see we can enter the client name. So I just call it NTI webinar. Then we have the object, which would be a hand vacuum cleaner sample. Here, maybe I could add the serial number or anything else, whatever you want. Then very important, I need to enter the measuring surface. You remember the value from our Excel sheet. In our case, it was 4.8 square meter. And I should enter the volume of my test room. And in this case, it is 66 cubic meter. Furthermore, up here to the right-hand side, you see the data, the date when our measurements were executed. This is related to the imported data. So you see that happened on the 14th of October. Now I can add a picture, a photo, for instance, of the device under test, or in my case, I select a picture of the test setup. You can see it here again. I can add a number of my report. Let's call it number 1. And I can select the date, the print date or the creation date of this report. For instance, today, 27th. So now here to the right-hand side, you see the list of all the measurement curves that have been imported. So I can select any of them and verify them. Do they make sense or not? Well, possibly I don't see that something is wrong, but on the next page, I will certainly get a better impression, because here, if I click on this icon on calculations, now here I see the average of the level measurements and of the background noise measurements. And I guess you immediately see something is wrong here. If I flip back, the background noise measurements were much lower than the level measurements. So why is that? Let us take a closer look. Here on the right-hand side, we see, for instance, these curves down here contributed to the average of the level measurements. If I go on average, I can do the same. And now all of a sudden I see, oh, okay, something's wrong here. This curve apparently was corrupt. Something went wrong here. So let us disable that. And all of a sudden, now the whole picture makes sense. This is now the average of our background measurements. So in this way, I can step through all my individual data. I can take a look at the correction curve. This is calculated by the software. The correction is or represents the correction of the background noise on the level measurement result. Then here I have the pink result, the reverberation time curves, and again the correction curve that is deducted from these reverberation time results. And last but not least, next step, I go to this picture here to results, and now I see the graph with the frequency results of my sound power measurement. A-weighted, LWA stands for A-weighted. Here on the left-hand side, I see the individual results, numerical, for the bands. Up here, you see this little asterisk informs you that there has been compensation with these correction curves. And now I have to resize that a little bit, because otherwise you don't see the bottom right corner. because there is this picture of me which I cannot remove. So here down here you see the overall result. This is the sound power value that we are looking for. This is the sound power A-weighted of our hand vacuum cleaner. And to already say that, when you compare this value with the specification given by the manufacturer, the specification is 80 dB. So you can see we are very close to the actual result. Maybe the manufacturer added some headroom to be on the safe side. So it just confirms we have made a correct measurement. Alternatively, we can also take a look at the Z, so the unweighted results in blue color. And again, here, this would be the sound power of the unweighted results. Well, let me get back to my PowerPoint presentation. Summarize the most important aspects. First of all, the Sound Power Reporter software is available free for download from our website. However, in order to use it, you need a license, either a permanent license, which is installed on the XL2, or you can also buy an online PC software license. So in that case, the computer by which you are using the PC software must be connected to the internet, but it gives you more freedom to limit the time you are using this license, for instance. Then when we talk about data acquisition and processing, you remember I was talking about this sound power profile. Actually, there are two files which you need to install on the XL2 in order to have this guided procedure. And for that purpose, you need to register under myNTIaudio.com. And when you enter there, you will find this paragraph here, Sound Power Reporter software. And here you will find the Sound Power profile and this Save Names file, both free for download to your PC. And as soon as you have downloaded these files, copy them to the SD card of your XL2. And the last thing you have to do is to enter the profile mode on the XL2, click on Manage, and then on Import from SD card. This will let the XL2 import and apply this profile in the internal memory. As stated before, next step would be to execute the measurements, level, background, reverberation time, import the data you have acquired in that way and review them if necessary. And the Sound Power Reporter will then, of course, calculate the corresponding result. And last but not least, you may customize your report, you may print it, and that gives you a nice proof that you have done your work versus your client. Well, that is actually what I wanted to show you today. I'm at the end of my presentation. Me from my side, I want to thank you very much for your attendance. I hope I was able to answer most of your questions. And of course, I would be very happy to meet you again at one of our future webinars. For the time being, have a good time, stay healthy. Thank you and bye-bye.